Section 3, production revisited from the perspective of countries. So here we assume that country produce good, value of two products. Anyway, this country produce two good because we assume two good factor model economy, right? So value of two products is like this. Maximize value of two product. Value of two product is price of good one multiplied by production of Q1 plus P2 Q2, right? That is value of two product. Value of two product is the same concept with GDP in nominal terms. Macroeconomics is simple. Macroeconomics assume that country produce only one good called GDP, right? So PQ is value of GDP. In macroeconomic version, V is equal to price GDP deflator multiplied by Q, right? GDP at constant level. In two good model, in here, P1, Q1 plus P2, Q2. So we can say that is very same concepts with value of the product, value of GDP, right? Rewriting this, Q2 is equal to V over P2 minus P1 over P2 Q1, right? That is iso value line. Iso value line in section 3.1, right? Subject to PPL, production possibility frontier. You study production possibility frontier in chapter 2 in Menkes Introduction to Economics book in simplistic version, and you full and detailed explanation of production possibility frontier is explained in intermediate level microeconomics, right? So, solve this one, right? To find optimal production bundles of two goods, Q1 star and Q2 star. That is value maximization problem, right? So, section 3, production revisited is same to the conclusion of section 2. Right? But we're talking about country's perspective because international trade usually occurred between countries, right? So we reformulating from the perspective of country. Anyway, conclusion is same, Q1 star, Q2 star, L1 star, L2 star, K1 star, K2 decided in this process, value maximization solution, right? I'd like to explain for PPL, production possibility frontier. Right? The definition of PPL is maximum production bundles of two goods this country can afford or produce with maximum with given labor and capital input. Okay? So think about this kind of condition. L1 plus L2 is L bar. In factors market, L bar is labor supply, right? Owned by household. This one sold, total labor supply, that is labor supply, and labor demand, L1 and L2. L1 is labor demand by firm producing Q1 or labor employment in sector 1. We already studied in production function, right? L2 is labor demand by firm producing Q2 or labor employment in sector 2, right? That's the labor demand. Should be equal to labor supply by household, right? Also, we know K1 plus K2 is K bar. Same thing happens. K bar is total capital supply by household, right? K1 plus K2 is capital demand by firms. K1 is capital demand by firm producing Q1. K2 is capital demand by firm producing Q2. Can you understand? Right? So from here we can construct PPL, right? PPL. This shape of PPF is for usually that is Q1, Q2 is like this. Maximum production bundles of two goods. Maximum production bundles of two goods, Q1 and Q2, this country can afford with given labor and capital. Right? That is production possibility frontier. So, if I explain a little more about this value maximization problem, ISO value line, Y variable is Q2, X variable is Q1, and Y equal A minus BX. In earlier my graphical illustration, this is a negative relation between Q1 and Q2. Q2 is Y variable, Q1 is X variable. X increase, then Y decrease. Right? And changing rate is minus P1 and P2. Right? Slope is P1 over P2. So ISO value line shaped like this. Right? Higher value, high value like this. Anyway, we can draw lots of ISO value line like this. This one is Q2 is equal to V P2 P1 over P2 Q1. That is ISO value line. So now think about maximizing value of the product from the perspective of country. That means all the country wants to reaching at higher level of GDP, want to touch highest GDP, highest ISO value line. But you have to specify PPF. Production should be occurred 1 point on the PPF. That is PPF, right? That is PPF. Production should be occur 1 point on this production, right? This one, production of this one is not possible because with this given labor and capital input, this country cannot reach at this production amount. Okay? So subject to PPM means production should be occurred 1 point on this PPM. And you want to touch highest ISO value line, highest GDP line. Now think about, if you production occurred at this point, GDP level crossing that point represented by this kind of ISO value line. If you choose this point, right, production occurred 1 point on this PPM, then you can draw ISO value line. Anyway, slope of ISO value line is same, every slope same, right? So the ISO value line crossing this point is like this. That means GDP level can increase if you production output mix change from here to here, right? If production occurred at this point, production also increase, GDP level increase. This one continues until reaching at this point, right? Or we start from here. If this country decides production bundles of Q1 to Q2 start here, 1 point on this PPA, GDP level should be like this, represented by ISO value line crossing that point. If you choose this point, then GDP level increase. We moving this way, GDP level increase and increase. We moving from here to here, GDP level increase and increase. And we can find only 1 point where GDP maximized. That is here. This point, we said Q star. Q star means Q1 star, Q2 star. Maximum optimal bundles of two goods, Q1 star and Q2 star, maximizing GDP or reaching at highest level of GDP. Okay? So this point. So at this point is 1 point on this production possibility frontier. Right? At the same time, this one, straight line, is maximize ISO value line, V star, or Q2 star and Q1 star. Right? From this figure, we know that, we already studied changing rate. Changing rate PPF at this point. Changing rate PPF at this point. How to calculate that? Draw straight line tangent at this point on PPF. And make any triangle, and you can calculate changing rate. absolute value of this changing rate, this slope. This slope of PPF, we said MRT, marginal rate of transformation, 241, right? This one, by definition, is equal to MC1 over MC2. That is slope of isovalue line, right? Also, now think about slope of isovalue line. This is the slope of PPF, and slope of isovalue line is P1 over P2. Changing rate is minus P1 over P2, and slope is P1 over P2. That is slope of isovalue line. That is slope of PPF. They are same. Why? Isovalue line at this Q star, at point Q star, is equivalent to the straight line when we use to calculate the slope of PPF at this point. Coincides, two straight line coincides. That means slope same. In other words, value maximization condition to reaching at this point, maximizing GDP, is P1 over P2, slope of isovalue line is equal to slope of PPF. Right? This one. And look at this. In section 2, right? That is a conclusion of section 3. In section 2, we said, for Q1 star decided by P1 is equal to MC1. Right? Profit maximization condition for Q2 to decide the optimal production of Q2 is P2 is equal to MC2. From here, we know that P1 over P2 is equal to MC1 over MC2, isn't it? That is perfectly same to here, the conclusion of isovalue line. Value maximization solution. Right? So section 2, conclusion of section 2 and section 3 are perfectly same thing. This one from the perspective of forms. This one from the perspective of country. That is perfectly same. Can you understand? Right? That is section 3. And after that, I explained that Q1 star, Q2 star decided by this condition. Then we can find equivalent labor and capital input mix. L1 star, K1 star, and L2 star, and K2 star. Right? So everything decided. That is overview of all of this one. So now I'd like to explain summary. Okay, section 4, summary. Summary is this one. As we already studied, how to solve utility maximization problem subject to budget constraint to find optimal consumption bundles of two goods, C1 star and C2 star, or optimal demand for good 1 and good 2. The condition for this is MRS, slope of indifference curve, right? Indifference curve is equal to relative price of good 1 in terms of good 2 faced by consumers, right? And section 3, we solve value maximization problem subject to production possibility frontier to find optimal production bundles of two goods, Q1 star and Q2 star, or optimal supply of two goods, Q1 star and Q2 star. The condition for this is P1 over P2, slope of isovalue line is slope of PPF, MRT. We studied this, right? And in addition, Q1 star, Q2 star decided anyway by cost minimization solution, L1 star, K1 star, L2 star, K2 star decided automatically, right? Anyway, we focus on this one and this one. Then, what is general equilibrium condition? This one and this condition satisfied simultaneously, right? This one and this one satisfied simultaneously. Then we can get MRS, slope of indifference curve, utility curve, is equal to P1 over P2 consumer base, right? Is equal to P1 over P2 firms supply, firms base when they sell their products at the market, Right? Anyway, this one is equal to this one. Okay? And MRT, slope of PPL. Okay? That is summary of microeconomic foundation. That is basic overview of general equilibrium. So you have to know all of this one. Okay? Now, then we go in this fourth section in more detail from now on. Okay, section 1, consumer behavior. So, as I said before, consumers solve this problem in too good to factor economic model. Utility function is like this, C1 and C2. Subject to budget constraint, P1, C1 plus P2, C2 is equal to M. M is income, P1, C1 is spending on good 1. And this is spending on good 2. Spending on too good cannot decide, cannot higher than your whole income. You cannot consume more than your income, simply talking. So budget constraint, first we're talking about this budget constraint. Budget constraint is the limit on the consumption bundles that the consumer can afford. The slope of budget constraint equals P1 over P2. Changing rate is minus P1 over P2. Right? This is the rate at which a consumer can trade C2 for C1. The relative price of good 1, right? Relative price of C1 in terms of C2. That is the meaning of slope of budget constraint, P1 over P2. Right? Next slide. Now we go indifference curve. Indifference curve. Right? Indifference curve shows consumption bundles that give the consumer the same level of satisfaction. Consumption bundles of two go. X variable is C1, Y variable is C2. So now think about at point A, this household consume 2 C1, A C2, A unit of C2 to reaching 4 level of utility level. Right? At point B, 4x1 plus 4y1, right? And total utility is 4, same. So A and B have different composition of C1 and C2, but total utility is same, right? Like this. So that is definition of indifference curve. Indifference curve shows combination bundles, large of combination bundle A, B, C, D, F, G, large of thing, provide you the same level of satisfaction U equal 4. Okay, that is definition of indifference curve. So for properties of indifference curve, higher one prefer to lower one. Higher one means more total utility, more utility. More one better than smaller one, right? And the indifference curves are downward sloping. Indifference curves are downward sloping, so negative relations, right? So negative relations like this. The slope, in other words, MRS is negative, right? Number 3, indifference curve do not cross. Number 4, indifference curve are bowed inward, right? Look at this, right? Indifference curve shaped like this. So bowed inward means this kind of thing, right? So in the graph explanation of graph, I already explained this kind of concept, right? So mu1 is total utility, partial derivative of total utility with respect to x or C1 is equal to C1 starting value plus increasing in C1, C2. And this is the original one like this, right? The slope of indifference curve is like this. mu1 change in C1 plus mu2 C2 is equal to same. Solving for the slope of the indifference curve, we have MRS is equal to like this, right? So some more explanation in graphs. So now think about one indifference curve, C1, C2. And utility function is C1 and C2, right? that is equal to some fixed unit, fixed util, for example. Then we can find lots of C1 and C2 combination providing same level of satisfaction. When we moving to here, we can make this kind of triangle, right? And we moving here like this. What happened? Changing the slope, decrease and decrease, right? So now think about this one, right? Changing in C2 over change in C1. Here, C2 is Y variable, C1 is X variable. We already studied in graphical illustration, right? Then what happened? Slope, changing rate is minus. So slope is positive, right? That is very acute triangle like this. This one like this, like this, like this. So we can get this kind of changing rate, right? I'm sorry, slope. Changing rate is negative, so like this, and absolute value is this, like this, right? That is MRS, slope of indifference curve. Indifference, MRS decrease as C1 increase. That is equal to what I'm talking about. So MRS is equal to mu1 over mu2, right? That is explained here. So changing rate is minus. This one is correct, but MRS in my notation is absolute numbers. So mu1 over mu2. That is should be positive. In some textbook, don't distinguish slope from changing rate. So lots of some confusion happen, but it's not so big problem, right? So like this, marginal rate of substitution. The rate at which a consumer is willing to trade one good for another. So at point A, slope of indifference curve is minus 5. Changing rate is minus 5. Slope is 5. What's the meaning of this? Consumer thinks one more consumption of good one, right? C1 is equivalent to 5 less consumption of good 2, right? That is meaning of minus 5. Slope is 5. But here, slope is 2, right? One hamburger is equivalent to 2 Cokes like this. I'd like to explain this one using graph, right? Anyway, how to solve utility maximization problem subject to budget constraint. Graphically, we can draw this indifference curve, utility function with lots of indifference curve like this, as I said before, right? Higher indifference curve prefer to lower one. That is, in total, we said this is the indifference map. Indifference map is equal to utility function. But consumers' consumption cannot exceed consumers' income. That is subject to budget, right? So y variable is C2, x variable is C1. So, and slope is P1 over P2, changing rate is minus P1 over P2. So we can draw this constraint like this. That is budget constraint equaling to this one, right? And slope of budget constraint is P1 over P2. Changing rate is minus P1 over P2, like this, right? C1, C2. Then, now think about here, changing rate, right? Now we focus on budget constraint. Slope of budget constraint is P1 over P2. That is slope of BC. Changing rate is minus P1 over P2, right? Minus P1 over P2, like this, right? And now think about this solution. Consumers choose consumption bundle on this budget constraint. 1 point should be 1 point on this budget constraint, right? So if consumers choose this point, then we know that consumers' utility level at this point is indifference curve, featured by indifference curve by this one, for example, U0, right? If you choose consumption bundle, what happen? Indifference curve, utility level increase. Why? Higher one prefer to lower one. This one increase. So we moving this consumption point. We know that utility level increase and increase. Now we're starting from here. If consumer choose consumption point at here, 1 point on this budget, then we can draw indifference curve like this. Right? If you choose this one, indifference curve like this. If you choose this one, indifference curve, increase, utility level increase and increase. Anyway, this level, utility level increase. This moving to this one, utility level increase. And we can find only 1 point here, where utility level maximized. Right? That is C star or C1 star and C2 star. At this consumption bundle, consumer face maximizing utility. Right? That is solution, graphical solution of utility maximization problem. Right? And slope of this budget constraint is every time P1 over P2, constant numbers. Right? Now think about indifference, slope of indifference curve. Right? That is U star, for example, slope of U star. Slope of U star moving from here to here, here. Triangle becomes smoother and smoother and smoother. Decrease and decrease and decrease. Right? So like this. That is slope of indifference curve, MRS. Consumption of good one increase with consumption of good two decrease. MRS decrease and decrease and decrease. Why? You have more good one and more good one. So additional consumption of good one, right? Increase total utility with smaller and smaller U level, right? So decrease and decrease and decrease. But relative price of good one in terms of good two same. But at this optimal consumption point, slope of indifference curve is equal to slope of budget constraint. Slope of budget constraint means P1 over P2. That is relative price of good one in terms of good two. Consumer face, for example, at the supermarket, consumer goes supermarket to purchase pizza or hamburger. Every time, price of pizza $10, price of hamburger $2. So exchange rate between two is same. One pizza is equivalent to 5 hamburger, right? Every time same. But consumers' price is different, right? If you are here, you have just one pizza, your utility, you get, now you have no pizza and 10 hamburger, right? You consume one more pizza and less hamburger. Your utility is here. That means if you want to consume one more pizza, you are willing to sacrifice, for example, 10 hamburgers, for example, right? So you take, but at this point, for example, you already have 10 pizza. So additional consumption of one more pan of pizza cannot increase your total utility. In other words, you're not willing to sacrifice just 2 hamburgers to get one additional pizza, right? This rate decrease and decrease and decrease. But that at this optimal point, same. MRS is equal to P1 over P2. P1 over P2 is relative price of good one in terms of good two at the market. That is objective rate, right? MRS is subjective rate evaluated by household, each consumer. You already have lots of pizza, your MRS is very low. You are willing to trade one pizza for example, 2 pizza for 2 hamburger for one pizza, right? But if you are here, you're eager to consume more pizza. In other words, you are willing to sacrifice 10 hamburgers to get one more pizza. So very high. This rate decreases and decreases. But at this optimal rate, optimal point, market rate is equal to your subjective rate, right? That is then C1 star, C2 star decided. Okay? That is graphical illustration of consumer's optimal choice. Now we go next slide. So I had explained here, budget constraint, and that is maximize utility. So optimal consumption bundles of two goods is 20 and 10. Okay? Here, two things are same. Look, right? At this optimal, this point on this budget constraint touching highest utility level, indifference curve. Tangent, indifference curve, tangent with budget constraint. Budget constraint, tangent, highest indifference curve. Okay, tangency in level function means slopes are same. I already explained, right? Slope, instantaneous slope of utility curve at this point. How to calculate? Draw straight line, tangent at this optimal point, draw straight line. And you know that this straight line coincides with budget constraint. In other words, slope of indifference curve at this point is equal to slope of budget constraint, right? So actually, demand curve is derived from this utility maximization problem. So this one is extracted from Mancu's Introduction to Economics book, right? So, for example, original budget constraint is like this. Now, budget constraint, price of Pepsi falls from $2 to $1. So then, budget constraint changed like this. Then, solution, optimal consumption bundle moving A to B, right? So, optimal consumption of Pepsi was 250 units at point A, but at point B, 750 units increased greatly. When price of Pepsi falls from $2 to $1. So when $2 at point A, demand for Pepsi was 250. Right? After decreasing price of Pepsi, consumption of Pepsi or demand for Pepsi increased to 750 units. $1, 750 units. So we can get this kind of demand curve. So demand curve derived from utility maximization problem. Okay? That is section 4. Also, section 5, I explain consumer surplus. So this one is extracted from Mancu's Introduction to Economics book. A buyer's willing to pay for a good. That is marginal utility. This is the maximum amount the buyer will pay for that good. Willingness to pay measures how much the buyer values the good. At the price to his willingness to pay, the buyer would be indifferent about buying the good. If the price is exactly the same as the value he placed on that good, he would be equally happy purchasing it or keeping his money. Okay? So it's famous one in one good model. So demand curve is actually marginal utility curve. We know that. Demand for example, Pepsi is like this, right? Demand curve, right? This is a marginal utility curve, marginal utility of Pepsi, simply talking, right? So now you're very thirsty, right? And if you drink one bottle of Pepsi, your utility increases greatly. In other words, you are willing to pay $25 to get first bottle of Pepsi. Your happiness increased by $25. So you're willing to pay $25. Now, when you drink 5 bottles of Pepsi, your utility increase, but smaller than before, only $18 worth. Okay? In other words, when you purchase 5th bottle of beer, you are willing to pay $17 only, like this, right? So marginal utility curve is like this. But market price is $10. So if you purchase and drink first bottle of Pepsi, your happiness increase, utility increased by $25, but you can purchase it only $10. The gap between the two is a consumer surplus from first bottle of Pepsi, right? This one, marginal utility minus your market rate, that is consumer surplus from second bottle of beer. In total is this triangle. We already studied this in introductory level microeconomics.